What's up, guys? I want to do a quick video on comparing substitution method with elimination method. Okay, so in reality, I would always use elimination method over substitution method. The only time I would ever select substitution method over elimination method is if I already have a variable isolated, like if it's ready to plug into the other equation. Okay, so I'm first going to show you substitution method, then I want to go back and compare it to elimination method. So because I have y equals some stuff right here, again, because you have a variable isolated, it doesn't matter if it's y equals or x equals, if you have a single letter equaling a variable expression, what you could do is take this variable expression and plug it into the equation, the other equation into that variable. Okay, so why am I plugging it into y? Because it says y equals a variable expression. So I plug in that variable expression into that variable. If I would have said x equals, then I would plug in this binomial into the x, if it would have said x equals. But it says y equals, so I'm plugging it into the y. Okay, so if I'm plugging it into the y, I want to have a new equation that reads 3x plus y equals 12. Now notice that I put parentheses in place of the y. And why is that? Because I am going to plug in this variable expression that y equals into the y. So this negative x minus 2 is going right in there. Let me plug that in. Negative x minus 2 goes right in there. Now you got to ask yourself, is there anything to distribute? Is there a number out here? No. Like sometimes you have a 2 in front of the y, which would have a 2 out here in front of the parentheses. Then you'd have to distribute the 2 to both terms. But since there is nothing here, there's just a plus sign, right? There's just a plus sign in front of y. If you distribute that plus sign, nothing happens, nothing changes. So what we have is 3x plus negative x, or you could just put minus x minus 2. In other words, the parentheses are not necessary, okay? And we do have it equal to 12. And now we could combine like terms, the 3x with the minus x. 3x take away x, that is 2x's. And then we have a minus 2 equals 12. And of course, to solve this, you're going to get rid of the minus 2 by adding 2. Adding 2, what you do to one side, do to the other. Your new equation will read 2x equals 14. And that's really saying 2 times x equals 14. So we already know the answer is 7, but let's show the work. How do you get rid of multiplication of 2 in front of the x? You divide by 2. That's the inverse operation. What you do to one side, do to the other. Divide by 2. And you will get your final answer, x equals 7. So we have one answer. We need the other. All you have to do is plug it back into any equation you want. I'm going to plug it into the bottom equation. It's actually easier to plug into because it says y equals negative x minus 2. Now, why did I put parentheses? Whoops, sorry about that. Minus 2. Whoops. There you go. So why did I put parentheses instead of x? That's because I know what x is. X is 7. So I want to take that 7 and plug it in right here. So what I really have is a minus 7 minus 2. So what is minus 7 minus 2? That's negative 9. So y equals negative 9 is my other answer. And of course, you're going to type it in as an ordered pair, 7 comma negative 9. Okay. Now, that is the only time I would actually apply the substitution method, when I have an equation that already has a variable isolated. So you don't have to use substitution. As a matter of fact, maybe even elimination method would be even faster than this process that we just did. So what I am going to do here is I am going to duplicate this problem, and I am going to solve it over again with linear combinations / elimination method, whatever you want to call it. So here it is. As you could see, the top equation is organized, right? We have it's in standard form. It has a number with an x plus y equals a number. That's the order that we want when we use linear combinations. You want your x's and y's on the left side of the equal sign, the number by itself on the right side. So the first equation is organized, but notice that the system itself is not organized. X is not on top of x, y is not on top of y, equal is not on top of equal, numbers not on top of numbers. So what we need to do is rearrange this bottom equation. This bottom equation right now is in slope-intercept form. If you were graphing it, that'd be good to keep it in this form, but we're not graphing. So what we need to do is rearrange it, move the x over to this side, so we could have x's and y's on the left side of the equal sign and the number negative 2 on the right side by itself. So I am going to add x, and my new equation will be exactly that, x plus y equals negative 2. Again, x plus y equals negative 2. That's what I'm going to write over here, x plus y equals negative 2. The top equation, I'm just going to leave it the same, 3x plus y equals 12, okay? So this is the new organized system that I need to work with, okay? So the question is, what do I choose to eliminate? I could cancel out x's by multiplying the bottom equation by -3, so it'll cancel with the +3, or I could choose to cancel out y's by simply multiplying the bottom equation by -1. That way the positive y and the negative y will cancel out. It's totally up to you. I am going to multiply the bottom equation by -1, put a -1 right in front of there. I'm going to distribute that -1 and change all the signs. So the top equation, I'm not going to change at all. It's going to be 3x plus y equals 12. The bottom equation will change to a -x minus y equals +2. Of course, take that negative, that becomes -x, that becomes a -y, that becomes a +2. There it is. So now that I have modified the bottom equation, I am now able to combine and cancel. When you combine, 3 take away 1, that is a 2x. And of course, the y and the positive y and the negative y, those eliminate. What do we have left? We have the 12 plus 2, which is 14. So we have equals 14, and this is a simple one-step equation. It really says 2 times x equals 14. So divide by 2. We do to one side, do to the other. Divide by 2. X equals 7. That is one answer. We still need the other answer. Now, mind you, we already have the answers. X equals 7 and y equals -9. We did this with substitution. But we are going to pretend that we don't know this, and we're going to plug this back into any equation we want. I'm going to plug it again into the bottom equation, and the bottom equation reads y equals -x with the negative sign in front. But that's ugly. Give me a second. And also -2 at the very end. So that x value of 7, we are plugging it back in. So we have a 7 right there. So we really have a -7 minus 2, which we know is y equals -9. So even if you compare this work right here and this work right here, it's pretty much the same amount of work, pretty much the same amount of time. And this is the only time I would actually use substitution method, when I have a variable by itself. So if you want, you could just completely forget about substitution and just make sure everything's organized. X is on top of x's, y is on top of y's, equal on top of equal, number on top of number, and then go about your business solving the system using linear combinations method, or whatever, elimination method, or whatever you want to call it. Anyways, I'm done. Just wanted to compare those two methods on the same system.